we discussed the recursive definition of a binary search tree, specifically what the search property is. And we also talk about if you perform in order traversal on a binary search tree, is going to demonstrate the so-called sorting property for the resulting sequence. That's what we said earlier. If you got any doubts, you should really review them before you move on to this week's contents. And in this week, we're going to talk about the various operations you can perform on a binary search tree, namely insertion, search, and deletion. But before that, I'd like to talk about briefly how you can implement a generic binary search tree in Java. And overall, there should be no surprise to you because the way we set up the classes is very similar to how we did it for the general tree. But I'm going to talk about them in just a moment. Let me switch to Eclipse first, just to show to you where you can find the relevant classes for your study and also exercises. Import the source project example BST, standing for binary search tree, and you will see two packages as usual. Under the model package, you will see the class BSTNode. This class here is very similar to the TreeNode class that we spoke about in the lecture earlier when we talked about general tree. But I'll highlight the differences, what you should really pay attention to really make it applicable to the binary search tree. I'll talk about it. And this class over here, in the same package, which is called BST Utilities. So this will be kind of the format we're assuming for the lecture examples and also for your maybe programming tests and even the exam. In the BST Utilities class, similar to like a list utilities or tree utility class, you will be asked to implement individual methods. For example, this one here, you're expected to return maybe some BSTNode. In this case, we're simply using array list just to show you how you can use the library classes maybe for your own developments beyond this course. And the one we want to demonstrate, which I'm going to talk about on my iPad in just a moment, which is about how you can perform in-order traversal on the binary search tree. And the way we supply the input binary search tree is by passing its root over here. And the root, of course, is a BSTNode. And notice that it's a generic parameter over here. Right, so everything here is quite familiar with what we studied before, so that's why I want to point it out to you just right away. It's not really surprising to learn this kind of stuff. Finally, if you look under the tests package over here, test BST, and we are going to illustrate two test scenarios. The first one is just about how you can construct a binary search tree from scratch, and the number two will be to illustrate about the search operations specifically for the binary search tree, which I will talk about conceptually first, and then we'll see how to implement them. There will be another two operations on the binary search tree, namely insertion and also deletion, which I wouldn't provide any source code to you, but they will be assigned as exercises for you. Of course, they will be based on how you perform search in the binary search tree. So I think you definitely got enough to really attempt and complete the exercises once you finish the current lecture. Alrighty, so that's about some heads up in the beginning. Let me now return back to the slides. The next three slides simply just contain the three Java classes which I just spoke about on the Eclipse. But let's now go over them one by one together. The first class is about the BSTNode class. Let me highlight it over here. And so that's the binary search tree node. And notice that it's generic. Let's look at what the attributes are, so we will know how to visualize them and how the runtime structure is like for the tree. If you look at that, so this part over here will be all the attributes that will be needed for a binary search tree node. So what do we have? We have the key, we have the value. Remember, we talked about an entry. An entry is going to contain both the key and the value. And you can see the key is always integer, and the value will be generic over here. And we got parent, we got left, and we got right. In some way, the complexity level for binary tree will be lower because we only got left and right, rather than maybe an array of child nodes or simply a singly linked list of child nodes. So in some ways, it's easier. How do we visualize a BST node at the runtime? Let's try that right away. So what's going to happen is for every BST node over here, and of course, I will try to show you a simpler way to visualize it, but this will be more complete just to understand from the beginning. So let's say that we might have a variable, maybe n, storing the reference of a BST node at the runtime. And the way you may want to visualize would be, let me divide this into maybe three parts over here, and then I'll show you exactly what I want to do. And the first one over here may be a reference for the parents. Right? You always have a unique parents, which can be null if the node is actually the root of the binary search tree. And the second compartments over here will be the key and also the value. So this can be the key, which always should be some integer. And also the value, which can be some object reference. It can be primitive or it can be reference type, which is more common. So this might be just pointing to some value over here, right? Just the value reference. And then we got both the left and the right. Okay, let me just fix this quickly over here. So if you really prefer, we can actually say this is a reference for the value. Okay, and we also got the left subtree and the right subtree. So this will be pointing to the root of the left subtree, the left child. And also this part over here will be the pointing to the root of the right subtree. So this will be the left and this will be the right. It's very important for you to visualize what a node is like in a binary tree or binary search tree. Of course, again, a binary search tree is simply just a binary tree that satisfies the search property, which we spoke about earlier. If you have any doubts, you may want to recall the information from last week, the earlier part of the lecture. Right, so these are all about the attributes for the BSTNode. Right, we're going to see example in just a moment about how we can construct different nodes and connect them together to form a tree. We got two constructors over here, and the first one is about BSTNode with no parameter, in which case every attribute will be assigned their default value. For example, integer will just be 0, and all other reference type will just be null. And this overloaded version for the constructor will be we're going to pass a key value and the reference value. Right? The key value over here and also some reference object for the value. And then inside over here, of course, we're going to initialize the key and value accordingly, the key and the value. But whereas the parents, the left subtree and the right subtree, they will just be null to begin with, which we'll expect maybe some other mutated methods to be invoked later. For the full definition for these two constructors, you can definitely look at the Eclipse coding, which I showed to you. Right, let's take a look at what methods do we have. Some very simple one. We can know whether or not the node is actually external. This will be very useful whenever you want to do traversal or maybe some recursive routine on the tree. So a tree will be external by definition. It will be if the left node is null and the right node is actually null, meaning that the node has no child nodes, just simply no children. So that's the very definition for an external node. And also, what does it really mean for the node to be internal as long as it's not external? So that will be acceptable, right? It's according to our definition. And we got the various accessors and mutators. And for the key, we got get key or set key, right? Always integer. For the value, we got get value and set value. And for the parents, we got get parents and set parents. And for the left and right, we got get and also set accordingly. And it's very important to note about the return type versus parameter type. For example, get parents, get left, and get right, their return type is actually some node, BSTNode. And in the case of the set methods over here, we simply return void, but the parameter type over here is just another BSTNode that's supposed to be passed by the clients. All right, it's a very quick walkthrough about the critical methods that we should really implement in order to make the BST node work in order to form a BST. And if you want to refer to the full implementation, look at the Eclipse source code I made available to you. And you definitely want to again compare about the previous and the next references in a doubly-linked node. Think about what's going to happen, right? Just very quickly. If I try to visualize what a doubly-linked node is like, in some ways very similar to a tree node. The only difference is when we talk about doubly-linked node, it's really meant for a linear data structure. On the other hand, this kind of structure over here is going to form a tree, which is non-linear, but they're kind of similar. Right? So if you look at that, it's going to be divided into three parts over here. And the first reference over there is going to be the previous reference. And the next reference over there will be the next reference. And then, so here will be the data objects, the elements. So this will be the previous, this will be the next, and this will be the data object, which will be the elements. They do share similarity. You can see the left and right is kind of similar to, well, actually, let me say it again. The parents is kind of similar to the previous. and the left or the right is similar to the next. However, you can see we said before, the fundamental difference between linear and nonlinear is about the branching structure. So again, this will demonstrate about the difference between linear and nonlinear. Think about these two references allow the data structure to really branch. This is what makes the branching possible, meaning that we got a nonlinear data structure. On the other hand, the next reference over here is less powerful than the left and right, in which case we don't really have any branching, so you always have the unique successor for you. In that case, it's linear. Right, the next over here, no branching is actually made possible. No branching. Meaning that it can only form a linear sequence. I think it would be nice for us to actually just review about nonlinear versus linear. Very important concept for you to know. Nonlinear versus linear over here. Alrighty, okay, knowing now we understood about the BSTNode, let's see how we can construct a tree accordingly. Let's now switch to the next class.